Hello, we are going to be doing trigonometry this section. It's going to be, I think, 7 or 8 videos total. I'm going to try to go as quickly but as reasonably as possible. And let's go and get started. This is going to be the first video on trigonometry. We're going to really be working on understanding the basic concept of right triangle trigonometry, like how it works. We'll also look at solving right triangle problems. These are definitely going to be some review, so hopefully you find it helpful. Trigonometry does come from the Greek, meaning triangle measuring. That comes from trigon would be triangle, metry is measure. So let's get into it. If I'm given this triangle here, and let's assume that it is a right triangle, then I can find 6 trig functions that are the ones that we'll use. The 6 trig functions are sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Now, sine theta, you may remember this when you studied trigonometry. Sine is opposite over hypotenuse, so we'll go to go opposite the angle, which is y. Hypotenuse is z, so sine theta is going to be y over z. Cosine theta is going to be adjacent over hypotenuse, and the adjacent to the angle is going to be x, so we have x over z. The tangent will be y over x, because that's going to be opposite over adjacent. Now, cosecant, secant, and cotangent theta are all reciprocals of sine, cosine, and tangent respectively. So cosecant theta is going to be z over y. Secant theta is going to be z over x. And tangent theta is going to, cotangent theta will be x over y. And I'm just going to clean up some of this writing here. The reciprocal trig functions are those last 3 that we did. So cosecant theta, secant theta, and cotangent theta will be your reciprocal trig functions. Here's basically how right triangle trigonometry works. Let's say that you are looking straight ahead. So imagine that this blue line is a straight line, and then you tilt your head up a little bit, and you make some angle here. Well, what happens when you do that is there's a series of points that can be formed between the red and the blue line if you're looking perpendicular. Now you'll notice of the lines that I drew, I just made 3 triangles. Each of these triangles, the smallest one, medium one, and the largest one, are all, and there's one word for it, they're all similar. And I use the abbreviation there for similar. And what the reason I know that these are all similar is because they all had the same angle theta, and they all have a 90-degree angle, which means that all these triangles have the same angles, so they are similar by AAA. That means that since all the angles are congruent, that all their sides are proportional. So if I have a triangle that has a side of 1 here and a hypotenuse of 2, and I say that this medium triangle is twice as big, then I know that this hypotenuse value will be 4. This is what trigonometry does. It relates one triangle with a given angle and says that all those other triangles that you make are proportional as long as you have the same theta each time in the right triangle. Sorry about that, I had a little technical difficulty. So again, as long as all these angles are the same, then I know that these triangles are proportional. And that's what trigonometry does. Sine theta is always going to relate the opposite and the hypotenuse side for a particular angle, because every triangle formed from that one angle, given that it's a right triangle, will have a particular proportion. We already went over the trick for memorizing sine, cosine, and tangent. That's going to be SOHCAHTOA, something you should know whether you're taking calculus or not, so you can do well with the math in college. Given the following right triangle, evaluate the following trig functions for alpha. So let's go and try this one. I'm given my hypotenuse and I'm given my adjacent side for alpha. They do tell me it's a right triangle, so let's go and find the opposite side. That's going to be the Pythagorean theorem. I'll call that side x. And we'll have 144 minus 25 equals x squared. I believe that's going to be 119. So x is going to be equal to the square root of 119. Only a positive value here. So the sine of alpha is root 119 over 12. The cosine of alpha is going to be 5 over 12. And the tangent of alpha is going to be root 119, the opposite over the adjacent, which is going to be 5. And then these are the reciprocals. And don't worry about rationalizing the denominator. I think in the next problem I do rationalize, but the AP class is never going to take off points if you do not rationalize your denominator. Okay, try this one on your own. Sine alpha is equal to 5 over 6. You want to sketch a triangle, and then find the remaining trig functions, all 6 trig functions. Resume the video when you're all ready. Okay, hopefully you got these answers. Here's my triangle. I was given sine first, so the triangle that I labeled, I put alpha in one corner, and I did my opposite over my hypotenuse. And then I found the remaining side, which was root 11, and then I was able to calculate each of these. Hopefully you didn't have too difficult of a time with that. Here we got Jon Snow from Game of Thrones. Go ahead and read the problem, try it on your own, and resume when you're ready to go. Okay, hopefully you didn't have too hard of a time with that one. Our favorite Game of Thrones character ends up standing, well, the wall looks like it's about 214 meters tall. I found that because the angle of elevation here was 37 degrees. My height is y, my horizontal distance is x. The distance from foot to top of the wall is 355.6 meters. So if I wanted to solve for y, I did need to use sine. And following this math, I got 214 meters. For the horizontal distance, I just used Pythagorean theorem here to get a 283.999 meters. One note I wanted to make, the AP tests will usually use 3 decimal places and no more, and we'll actually not do any less either. We'll usually stay at 3 decimal places unless stated otherwise. Now, we're going to look at graphing these. So there's a little mnemonic that we can use. It's ASTC. Some students remember this as all students take calculus. And here's what it means. The A means that every single trig function, sine, cosine, tangent, and their reciprocals will all have a positive value in the first quadrant. If we go to the second value, though, the trig function that we know with S is sine, so sine will be only the positive one, which means cosine and tangent are both going to be negative. For quadrant 3, the t is going to be positive, which means tangent is going to be positive. That also implies that cosine and sine are both negative. Finally, the c here in the fourth quadrant is going to mean that cosine is the only one that's positive. This does imply that sine and tangent are both negative. ASTC. If you start in quadrant 1 and label them, then you know that in quadrant 3, the T stands for tan, and tan is positive. Again, ASTC tells you where the values are positive only. This should help us in our next problem. Given the point 4, -3, find the 6 trig functions. So the 6 trig are going to be, we need to draw a picture here first. 4 and -3 will be down here. This will be 4, this will be -3. This will be theta. And it looks like I'm going to need to find this hypotenuse, and I believe it's going to be 5. If I do 4 squared plus -3 squared and take the square root, I'm going to get 5. So that means sine of theta, remember ASTC, it looks like cosine is going to be the only one positive, so sine theta is going to be a opposite over hypotenuse, so -3/5. Cosine theta is going to be adjacent over hypotenuse, and that is a positive value, which is what I want. Tangent theta will be -3/4. And then we'll do the reciprocals. Cosecant of theta, secant theta, and cotangent theta. Okay, next problem. Find tangent theta given that cosine theta is equal to -4/5 and theta lies in quadrant 3. So let's go and draw that picture and see what we have going on here. Remember, cosine is negative in these two quadrants. And when it says theta lies in quadrant 3, that means we're looking at this one here. So we're going to have a -4/5. -4 will be the adjacent side for theta. 5 will be the hypotenuse. 3 will also be negative because, again, we are in the third quadrant and the vertical distance is negative in the third quadrant. That means tangent theta is going to be -3/-4, which is going to be +3/4. A quick term review. If I start with this side is called the initial side of the angle. This ray is going to be the terminal side. And I'm assuming that the angle opened up in this direction. It rotated in that direction. The next problem we'll use this side, we'll use the term terminal side and initial side. So let's state the quadrant. Well, I lied. I thought it did, but I don't think I put that problem in here. State the quadrant where theta lies when sine theta is positive and cosine theta is negative. Remember ASTC. So sine is positive here, and sine is positive also here in the first quadrant. Cosine theta is negative, while cosine is positive in these two quadrants, 1 and 4, which means cosine theta is negative in quadrants 2 and quadrants 3. It looks like we have both our check marks here, and that's where our answer is going to be, quadrant 2. Try the next one on your own. Okay, hopefully you got secant theta is going to be where x is positive because secant theta was cosine, and cosine is positive in quadrants 1 and 2. That's why I have green check marks there. I'm sorry, 1 and 4. That's why I have green check marks there. And cotangent is negative. Well, this was a tricky one. Y has to be negative and x has to be negative. But since we said x is positive already, then y must be negative. And the y values are negative in quadrants 3 and 4. And since I have my two blue and green check marks in quadrant 4 should be the answer. Thanks for watching the video, guys.